Welcome to day 2 of the OPI event. I just wanted to start today just with a clarification on some naming, just to help people out throughout the day. This is a community building event. A lot of people were invited to come and show their perspectives. But for naming wise, a couple of different open source projects are coming together to form this OPI community. So you will hear, IPDK and Diamond Bluff potentially both mentioned. So depending on which side you came in from, this is really a gathering of both of those communities coming together to form OPI and inviting participation from the broader community. So just wanted to clarify that as we start. And I'm going to turn it over to Susan as our Master of Ceremonies to get us started.
Thanks, Chris. So this is Susan Buffholz. I'm from Intel. I'm going to be your moderator, just like yesterday. We have another really exciting day planned. As we did yesterday, please use the chat feature to ask your questions. Right now, I'm really excited to introduce our keynote speaker, Denis Kennelly from IBM Storage General Manager.
Thank you, Susan. Good morning, good afternoon, good evening, everybody. Denis Kennelly here. Let me get the share going here for a second now. If I can get this, get my share going, and then we get into this. So hopefully everybody can see this. Okay. Eventually got through that. So as I said, my name is Denis Kennelly. I run the storage business for IBM. And actually with me on the call today as well is a gentleman by the name of Vincent, who is my CTO for IBM Storage. So between Vincent and I, we'll tag team a little bit through this presentation. As Susan has said, and if you have questions, please put them in the chat bot or the chat window, and we can talk about those. But look forward to interaction. As we looked at this and looked at the need for an open interfaces for DPUs, etc., I really wanted us to kind of take a step back and think about how, as we look at what are the kind of some of the business drivers around some of this capability, and really talk about when we look at it within IBM. We talk a lot about the hybrid cloud and the hybrid cloud journey, and really build a case for that. What the role of accelerators, both DPUs and SmartNics, have in that, and where we see those playing a critical role as we build out that platform not across IBM and Red Hat, but across the industry. And also, of course, what is going to be critical for this for any platform is the ecosystem and the openness around that. And then we're going to talk about, some real examples of where we're using this technology today, and where we are looking to develop that, and also looking forward, with my storage hat on, and looking at potential use cases for this technology and how we're leveraging it in storage and across the infrastructure. So as we think about this, and kind of the abstract for this discussion is, I really wanted to come from kind of a business view outside in. And, a lot of us talk about, you hear a lot of talk about digital transformation happening and the rate and pace of digital transformation. And what are kind of some of the key business drivers for that? And then obviously, what are the secondary requirements as it looks to the infrastructure as we go through that digital transformation? And for me, I think that, when I look at digital transformation in a lot of enterprises and the business requirements, there are kind of like 3 key drivers in there. Number one is, business is looking for agility, rate and pace, the ability to offer new services, digital services, B2B, B2C, the different scenarios, but being able to offer that at pace, to try out new services, see what's working, what's resonating, if you need to pivot quickly, and be able to do that in a very agile manner. Data is obviously the new oil of the industry, of our IT industry, and being able to leverage data that is right across the enterprise, and how you actually can monetize that for value within your enterprise. That's really critical for a lot of enterprises today. And how you get access to this data, because in a lot of cases, this data is housed inside both legacy systems and new systems, and how do you get insights from that quickly? And then, of course, when it comes to actually deploying these services, that the customer has choice, be it on a public cloud, in a private cloud, out at the edge, depending on the services. We cannot dictate those. And they're kind of some of the critical requirements that we see happening from a business perspective. But now when you bring that down into what infrastructure needs to do and what we're calling infrastructure modernization, and what are kind of some of the key attributes we really need to think about as we build out infrastructures. Number one, first and foremost, traditionally we've built infrastructure almost dictated by an application in the worst case scenario. But clearly in a cloud model, you got to get to that scaling type model. So you scale up to meet the needs of the business and scale back as those needs dissipate and change over time. So clearly that elastic scaling model is vitally important. Secondly, as we look at things like choice and portability of choice, and the customer has choice of deployment models, being able to deploy these application services, whatever you want to call them or define them as, in different environments, and saying not one size fits all, and having that portability of the environment. And of course, given the world we live in, even more so than today, is how do you think about security and how do you secure these environments? Because while, if you look at a hybrid cloud and it gives you a lot of flexibility and scaling, et cetera, across the environment, the security problem even more so is so critical. And how do you build security into that type of an infrastructure? And the role that, the DPU, SmartNic technology have to play in that. And that's what we really want to build the case of why they're so vital to everything I've talked about in terms of how we drive the infrastructure and meet those business requirements. So kind of peeling back a little bit, how we got here, right? And where that digital transformation is happening today. On the left-hand side, at the end of the day, the customer is at the center of all this, how we transform the customer experience. Provide that, and sometimes you hear it called that 360 view. But at the end of the day, what this means is that we can build services and attract new customers and retain and monetize the value around your customer and build new services to that customer. The business drivers being how we actually build new channels, new opportunities, new distribution channels. The customer here could be a consumer, could be another business, it's business to business, and actually building that, driving that capability in a very agile fashion. So as you deliver on those business requirements, underpinning that is the ability to build and deploy applications really quickly, the ability to leverage the insights and the data that's in the enterprise today to actually be able to define and build those new offerings for those customers. And also how you actually look at how you execute business or these business processes and transform those with workflows and intelligent automation over time. All of those capabilities of that transformation is enabled through what we call the hybrid cloud, because we want to make sure that you have complete flexibility, because you cannot say one size fits all. A lot of these, based on compliance requirements and many other reasons, will require a hybrid cloud that can run in a hyperscaler public cloud, on-premise, or all the ways out to the edge, and depending on the environment. And another core foundational technology in that, as we leverage data, is obviously our AI capabilities that sit inside that. So then, that's kind of the business view and the kind of the building blocks. If you look from an operational perspective and how this all comes to life as we actually start to build out this and deliver these capabilities, if we go from top to bottom, really traditionally, we were on-prem, virtual machines, and now, we're starting to shift, and we have shifted into that container world, and to be able to, and into serverless type applications, and being able to deploy these in a myriad of different environments. When you start to look at, the developer or the development processes or the developer persona that's in all this, traditionally we were in a waterfall model, full stack custom development. We build the application top to bottom. It was monolithic, transactional. Whereas now we're in a world where we want to get into a more composable application where you actually start to build microservices and stateless, etc. And also what's really important is how we blend, because it isn't a blank sheet of paper. As we talk to clients, you're going to get these blends of worlds, right? You can't just say it's all cloud native, stateless, serverless. You know, you have to, there's also existing applications, existing code. And in an ideal world, yes, you modernize everything, but you're going to have a hybrid model of existing services. How you leverage microservices with some of the traditional monolithic approaches, and dealing with data transactional versus consistent data. When it comes to security, our traditional approach was let's build a big ring or a big perimeter around it, a big wall, and keep what we often say is the bad people out or the bad guys out. It was the way we traditionally did it. When you're in this hybrid, distributed world that runs across these different environments, there is no perimeter anymore. The only thing that's unique across these environments is probably an identity. And how do you manage that in this type of environment, where even an identity may not be a person, it could be an API call associated with another application that could be impacted. How you deal with compliance issues, whether manual checking, which is what we traditionally did, it really has to be automated. It has to be inbuilt to be able to prove compliance to the regulator across these highly complex applications. And last but not least, in terms of how we manage it, I mean, traditionally, again, we put sensors everywhere, we built a view of the application, and we kind of nailed it up and presented that and said, this is how it's operating. And then, today, obviously, that doesn't scale, that doesn't work for these stateless applications that are elastically scaling and moving about. So the role of SRE and how you build that into the environment is critical. So it's a complex world, and as you look at this this hybrid infrastructure, we have kind of stepped back and looked at this from a business perspective, and looked at what we've done traditionally in terms of these environments. I mean, on the left is kind of where we were probably 10, 20 years ago. We tended to build infrastructure which was really tuned for typical application type stacks. And really it was sized and built to meet the kind of the worst case scenario, so to speak, for that application or service deployment. And all of these were tuned and siloed to some extent, and how we deploy them was highly manual. And of course, when you're operating these environments, very difficult communication. You had to have deep knowledge in how it operated. There was a lack of tooling, a lack of consistency. And teams were all very siloed across these environments, which led to spiraling costs. Now, and then, somewhere in the middle, we moved to a cloud model, which has a lot of these attributes. But when we think about cloud, if I think back 10, 15 years ago, when say 10 years ago, the thinking was everything is going to go to a public cloud hyperscaler and that's it, we're done. That hasn't proved to be true for a lot of reasons, right? But there was a lot of goodness and a lot of learnings from those hyperscalers. It has, for compliance reasons, for existing systems, etc. It hasn't been easy to move them to a public cloud model only. And this is why, we're getting to this hybrid cloud operating model, which brings a lot of the value that has been driven by cloud around developer productivity, how you do collaboration, those cloud native capabilities around elastic scaling, etc., and how you automate the software lifecycle, and do that in a consistent manner across this hybrid cloud platform. And we have, looked at this from a business perspective in terms of the value that, a hybrid cloud platform brings to our clients versus a public cloud only. And that research is showing along 5 vectors that we can deliver 2.5 times more business value with a hybrid cloud platform. And those 5 vectors being business acceleration, which talks about the rate and pace of deploying applications, developer productivity, which is really tied to that, infrastructure cost efficiency, making sure that you deploy your service or application on the most cost optimal infrastructure. And there are, this is really becoming a bigger focus right now for CIOs and CTOs and architects. Of course, making sure you're considering regulatory and compliance and security issues. And you have what we call strategic optionality. That's that portability layer, so that you're not tied to one specific platform, but you have choice as you look across these environments. So kind of unpacking that a little bit more and talking about, some of those, because I'm getting to, the role of DPUs, etc. But, what are some of the characteristics of that hybrid cloud platform that, we see 2.5 times more business value, and what are really critical attributes to that? And one is this level of what we call application and data portability. Being able to build your application and service and deploy it anywhere and manage it consistently. And being able to place workloads and applications at the most optimal locations. If you have data latency requirements, where do you place the application relative to the data location? Where you want to have differentiated services, maybe some cloud service has some very unique capability you want, and be able to selectively integrate those into the environment. And having an operating model that's consistent, both from an operations perspective, but also from a security perspective, and be able to standardize in that. So really talking about how you deploy your applications and being able to do that in a consistent way. And the underpinning technology that clearly the IBM company in conjunction with Red Hat that we have bet on are containers to enable a lot of that application and data portability, because that effectively gives you that layer of abstraction. And also give you this next layer, which is really around elasticity. I talked about the resource allocation and the need for resources depending on the application, being able to scale up and scale down depending on the workload requirements. The traditional approach was to deploy an application based on a worst case set of scenarios. Obviously, that's not cost efficient, doesn't make sense in a cloud model. So being able to adapt resource allocations to the environment. And again, with containers and in conjunction with Kubernetes, you get that elasticity layer and being able to do that. And being able to do that right across the environment. And last but not least is, security. Clearly, the world we live in today, and even more so in what's happening right now, that, security has to be core to everything we do. And being able to, be able to identify the right access. I talked about, the perimeter. The traditional approach was to build a perimeter, but there is no perimeter today. It's really all about access, and access to the right people or the right applications or to the right data in the right environment, and being able to manage that consistently across the environment. Being able to protect against, attacks, and obviously the one that's always in the news today is around ransomware, how you protect against that. But the sad reality is that knowing the fact that you're probably going to get attacked, and how do you recover really quickly from those environments, and how do you build that capability into the infrastructure, and being able to show consistency and risk mitigation to the auditors as you look at that environment. So these three are some of the core building blocks of that infrastructure that we're talking about. So now bringing it to to the DPU, IPU world, and kind of like where we see, as I talked about that hybrid cloud platform, or that platform that we're talking about here, we're building, I've talked about a lot of capabilities here in terms of requirements and the need for infrastructure to deliver. And all of those capabilities, require compute and resource to actually make it happen. And as you start to think about infrastructure services such as hypervisors or container management platforms or Kubernetes, software-defined storage, software-defined networking, a lot of the stuff I talked about in security. When you look at this in this total, it can take up to 30% of the overall system resource. While it gives you tremendous flexibility, the fact is that, and especially this is becoming a real issue right now in some of the, the current infrastructures, things like hyperconverged and other things, where the cost to actually run the infrastructure is really taking from the actual application itself. And how do we actually make sure we have composable systems that have a more flexible resource scaling between these infrastructure services, of which we need to add more to give a lot of these capabilities. I mean, we're not done. There's more and more we're adding every day, and these business applications. And that's a critical piece of where I think DPUs, et cetera, have a major role to play and how you build that isolation. And speaking of isolation, as you actually start to think about this and think about, what we are building, on the one hand, it's a bit of a contradiction, right? We want to have consistency. We want to make sure everything is consistent across the environment, whether it's at the core, the edge, or in the cloud, and making sure we can operate secure in a consistent manner. That gives us tremendous flexibility from an operational perspective. In a contradictory way, when you put your head in yourself in the shoes of the attacker or somebody that poses a threat to your environment, the fact that everything is consistent means that if that person gets one entry point, they can consistently get across the entire environment quite easily and do lateral movement and all the stuff we talk about in the security context. So, how do you actually, protect an application in that environment? How do you actually build that layer of isolation and make sure that, that if somebody does get in at an application level, that they can do lateral movement right across the entire infrastructure and pose a threat to the entire environment, which is a really important aspect of this, where DPUs and IPUs have a critical role to play in terms of building that environment. So if you think about it, there are kind of two main drivers that really we are looking at here right now, which is that layer of almost being able to measure the impact of these services, of which there are going to be more, and being able to isolate them from a compute perspective, but then also from a securities perspective, being able to build that isolation and be able to make sure that we can have abstraction across the environment. Now, so as we think about this and look at this technology and making sure that we get full adoption, because looking at these technologies, they are quite interesting, but like all technologies, the best technology doesn't always win. The one that wins is the one that gets most adoption. And being able to create an ecosystem around that everybody feels comfortable in operating in and can bet their technology and their future around. And that's why we need a very open ecosystem, leverages the open communities, and make sure that we can drive adoption. I mean, clearly, I have a chart here which shows examples with our colleagues from Red Hat where we've done this very successfully around containers. There's a technology that's out there now for a number of years, but making sure you're driving, you're leveraging the open community innovation around containers and Kubernetes, which is absolutely incredible, and the rate and pace that drives. But also making sure that you build an ecosystem of partners around that can use that technology in a consistent way and bring it to the enterprise in a consistent way. Because open source innovation is great, but without those enterprise features, those hardening features, and making sure you can do that consistently across the environment. Back to this consistent, you get a lot of one-offs and a lot of one-off, we'll say, forking going on, unless you do that in a consistent way. And as we do drive this open innovation, making sure we have an open ecosystem around that is critical, as is the example that we have with Red Hat and Kubernetes. So now, kind of getting to, and I'll bring Vincent in here as well to talk a little bit more about these in detail, right? We are leveraging, SmartNic and DPU technology today within IBM. One of the places that we are doing it quite effectively is in the IBM public cloud to provide, secure isolation. I talked about that isolation between the infrastructure and the application in a multi-tenant environment, and that's a real example of that. Also, our AI team, and we have some research here as well in the AI world, and we're using that with some third parties in terms of a data inferencing platform. So I don't know, Vincent, do you want to add to that or talk a little bit more detail?
Yeah, so yesterday can you hear me okay? So yeah, so yesterday from the conversation from Meta's presentation or Newtonic presentation, both are talking about from the AI aspect, right? How does people are looking to leveraging DPU, IPU sort of technology to accelerate AI. And the right-hand side picture that I want to share with everybody that IBM is partnering with this company called New Realities, create this the AI over Fabric network with a full AI pipeline offloads, the Hardware-based AI hypervisor capability to be able to offload the intelligent inferencing capability in the network device. So this is just one example. IBM has we have been noticed the DPU and IPU possibility and potentials. So this is just two examples, two projects that Denis showed here. I mean, there are other projects that we can talk. There are a lot of opportunity, as you can see from yesterday's meeting. But this is just two examples that we show that we have available today. Yeah,
and then kind of bringing it close to home, given Vincent and I both work in storage, right? One of the big challenges, I talked about security. We talk about data protection and protecting data. In the world of storage, this is becoming front and center, right? We're closest to the data when it gets into that persistent layer. And we're the last line of defense when you really think about it, right? When all else fails, right? And when you have an attack going on, either when your data doesn't get encrypted or there's a data leak going on or whatever, we're kind of the last post of standing, the last person standing. And we're looking really hard at host-based encryption, and obviously, which is out there today, right? But looking at DPU technology and how we can guarantee in the data center that you can keep your own key and make sure while you get that host-based encryption, the other challenge is obviously when it comes to a lot of storage technology, the compression rates start to fall if the data is encrypted. So doing some very unique things where we can guarantee the compression and duplication rates for encrypted data and leveraging DPU and IP technology to make that happen. Something we call smart host-based encryption. And that will continue to allow the data reduction rates. Because no matter what anybody says, when you have encrypted data, the storage device is not able to get to that data reduction rate. But we have some unique capability that we are leveraging DPUs to make that happen. Maybe Vincent, you want to go a bit deeper on that and talk a little bit more without getting into too much of the IP detail.
Yeah, so this is a real problem, right? People, for the last decades, if you will, that people are comfortable with the data encryption for data at rest. But everybody know that in terms of end-to-end security, that is no longer suffice. There are more and more people look at it at a higher level encryption. The problem is once you move the encryption capability to the host levels or network levels, that if you want to persist the encryption, from end to end, then it's very difficult for storage to be able to do data reductions. And we have the example number one here, exhibit number one here is we do see customer that doing this one and doing this kind of host-based encryptions, and the trade-off is the storage the consumption sort of grew, and to accommodate this solutions, that people had to spend a lot of time to figure out that do the data classifications. The most critical data do the host-based encryption. The less important one do the device level encryptions. And as everybody know, nobody has time. Nobody's interested to spend more time on data classifications. So in the industry, there are people that inventing a second way to solve this problem. How about we just pass the key to storage, and storage can decrypt the data, and then we can do the data reduction. Then we re-encrypt it with the key, and then we can put the data, encrypt the data on a media. Well, that sort of solved the problem, if you will. So you can enjoy the host-based encryption as well as the device level data reduction. But the problem is that there's a tiny window there that the key has to be shared. So the question that the question we are trying to explore is, are we able to leveraging the DPU now that with the DPU and IPU sort of technology is available to us? Can we create a smarter, host-based encryption to allow us to be able to accommodate the storage level reduction? So it's like you have the cake and eat it too, right? You can enjoy the host-based encryption in the meantime that you don't sacrifice the data storage efficiencies. So this is the things that we are actively looking at right now.
Thanks, Vincent. So, to summarize, I mean, if you go back to what we said at the very start, right? We see it's a hybrid cloud world. I mean, there's no great revelation there, right? I think the whole industry is there. We see a world where, we need to build more of these infrastructure services into the infrastructures to enable those cloud-like attributes of elasticity, scaling, agility, and more importantly, that we can make sure we can secure these environments inline rather than after the fact. As you start to think about that, then you actually want to, what is the payload for those infrastructure services? Because right now that is competing with the application payload. The role of DPUs, IPUs are critical there, so we can offload those infrastructure services into those DPUs. And having an open ecosystem for us to do that in a consistent manner is so critical, because we got to do that right across this environment. And there are some real live examples that we've just shown you, which is, here's this one of the chart here, where we are bringing, increased value add with a security service for encrypted data for storage, which can give you the benefits of deduplication and compression, but also allow you to do host-based encryption and you, the customer, to keep your key. Being able to do that in a consistent manner is critical. And while we are, very much supportive of this approach and making sure we have an open environment, a la what was done with containers and Kubernetes, to actually to bring this DPU technology and make it mainstream right across these hybrid cloud infrastructures. So with that, I just want to thank everybody on behalf of Vincent and I, on behalf of IBM. And I will, at this stage, open it up to questions, comments, Susan, and anybody who has put stuff in the chat.
Yeah, so I'd encourage everybody to ask questions, throw it into the chat, and we'll read them out. To get things started, I'm going to pull out a question that we gave to a couple folks yesterday. Explain the importance of pushing software and drivers upstream in a timely manner. How important is that to IBM storage?
When you say software drivers upstream, just give me a bit more context.
Going into the Linux community, for instance, making sure that everything gets pushed into the Linux community.
Okay, sorry. I think, if you look at, I suppose, I've been in this business too long, right? And if I look back over the last 30 plus years, right? We lived in a world of multiple operating systems, multiple environments. And if you think about some of the stuff I talked about, was you built infrastructure almost for an application type, way back when. But we've quickly come to the realization we got to have consistency, and that was really what Linux brought to the table, right? And making sure we have that open community so you can have a standardized infrastructure at an operating system level. And this is, and that's a kind of a core building block. If I think about Linux, I think about containers, I think about Kubernetes, they've all followed that pattern, right, of a community-based open approach. And when I think about this technology evolution, it needs to follow the same thing. And it's critically important that the community are part of that. It's part of the Linux community. And as we build these drivers, etc., do that in a consistent manner. Because we have a community out there, we don't need another one. We need to leverage what we have out there today. Vincent, anything you want to add to that?
Nope, I think this is good.
Alrighty, can you talk at all about the performance targets needed for host-side encryption?
Okay, let me take this question, Dennis. So the reason why I think Rob, we talked about the things in the meeting between IBM and Intel here. So the target, of course, is we try to get to that line rate as close as possible. Here are the things that you don't want people to trade off. That do you want performance or you want security? The same thing that, we just talked about our technology. We were thinking about the technology that you don't want people to trade off that you want security or you want storage efficiencies. So it's sort of like, hey, if you sell a car today, you want to ask people that, do you want a horsepower or you want an airbag? Well, you kind of need both, right? So, or, fuel efficiencies. So the goal is try to get as line rate as possible. And that is why DPU and IPU present a new opportunity, right? If it is just another, general purpose processors inside another computers, then it doesn't really help, right? We're trying to leverage the A6 or FPGA capability in DPU to get us as close as the line rate as possible. I would say that, in general, rule of thumbs is if 10% degradation, nobody will complain about it. But we actually tried a software version of that. The degradation is beyond, is more than the 50-60%, then nobody will, nobody will want to do that, right? Just today, if you buy a car, if you in order to get an airbag, your horsepower cut in half, and I don't think anybody gonna buy the car. Okay.
Thank you. Next question. Would you imagine opening up storage systems for users to program their own specific functions, such as shipping functions to the storage to accelerate processing?
Yeah, I'll start with this one. Right? I think as we start to think about storage and it's becoming more software defined, if we look over, the next number of years, I think we will get to that world where we will see, traditionally storage, the storage system has a certain set of functions, it's somewhat closed. But as you get into these more open software-defined worlds, I do see that happening. And I think what we're talking about here is a classic example, right? So, where the example we use of host-based encryption and compression, right? And with an ecosystem built around this DPU technology, I could see a myriad of use cases where where you think about computational storage, depending on the data type and depending on the data processing, that you could actually start to offload some of that function for very specific environments. We've talked about host-based encryption as a use case, right? But you could think of data processing, deduplication, record management. I think we are going to get to that world and open up that storage world. And that's something we haven't talked about here, but we are actively working on is a software-defined storage stack that enables that to happen. And it's very much tuned to the container Kubernetes world, but that's where we see the industry going, absolutely.
Thank you. Next question. For the storage use case, are you considering using DPUs to pre-process data before leaving the storage system? Would that help the network bottlenecks that others talked about yesterday?
Yeah, I think, well, yes, I think is the short answer, right? We are looking at how DPUs, but I'll be candid, right? For us to bet, it's really that open piece is going to be really important, how that becomes mainstream, and making sure we can do that in a consistent way. I mean, if you think about it, some of the stuff that we're doing here around the encryption, that's exactly what's going on, right? We're pre-processing, right? And I think, as we do more of that, then I think, yeah, but we want to make sure that that becomes a consistent way to do that right across the environment. And we just don't become a unicorn or something that's unique in the environment. And that's why this openness is so important. Vincent, anything you want to add to that?
No, I think that you are absolutely correct. And, Titan, yesterday, I think there are a lot of conversation about, the world needs a smarter storage because the data is getting more and more, and then the parameter for AI training is getting harder and harder. Meta talking about the synchronized trainings. You need so much data. So there's a new evolution that need to happen in the storage area, and people are exploring that, whether we can, leveraging the DPU technology to make storage more intelligent, leveraging the, the A6 and FPGA capability in storage. And, there's definitely an opportunity, but I'd like to echo what Denis is talking about. We cannot afford to hard code it for particular, the DPU or IPU technology. We desperately need the ecosystem to allow us to be able to make our application portables.
And just to kind of give you, as I talk to a lot of clients every other day of the week, I mentioned up front at a high level, leveraging data. Where is the data today, right? It's everywhere, right? It's in all these systems. And then, so you kind of have data, what I call scattered all over the environment. And then, you have the data scientists and the AI guys come along and say, we want to build models. And they start to pull the data. And that's been, unfortunately, 80% of their effort is just getting clean data. And usually ends up copying that data to another location, and then they do processing and clean up and dedupe and all that stuff. Those functions, right, they need to be inherent to the storage, right? We are looking at things right now, where, because at the end of the day, depending on data types, etc., it's the 80% rule, right? So caching and stuff like that is what's critical, right? You access the same data 80% of the time. So functions like that, DPU lends itself to implementing those caches and data and making sure we can do that in a very performant way, because of these highly distributed environments where, you want to build these models, pulling the data out, etc., is what's really constraining them today. And that's where there's a big opportunity.
Great. Next question. Has IBM Cloud adopted DPU technology as part of their cloud infrastructure? If so, do you think this approach will work well for private clouds as well?
Yeah, IBM Cloud has adopted DPU/SmartNic technologies, and right now they are leveraging that. The first step is leveraging that for the security isolations, and they are looking at down the road with this software-defined storage offload and stuff like this. So the question is, does it approach work for private clouds? I absolutely believe this will work for private cloud. There's no reason why this will not. In fact, I think that this kind of the connectivities should be a evolutionary technology for the hybrid cloud. Once you start connecting the private cloud and public cloud together, and this could be a works as agent to connecting those fabric together.
Yeah.
Thank you. This will be our last question. One way I'm looking at this effort is in terms of making platforms more secure. How do you see security in the context of storage and this effort?
Yeah, so, having spent some time in the security world, right? At the end of the day, we build a lot of capabilities in security and services that really look at the environment. When you think about data security, encryption being an example, data classification, where's your critical data, who is accessing it, all those functions, right? They traditionally have been done up at a host level, and they're very intrusive, not alone from a data perspective, but from a processing perspective, and being able to do these things, as Vincent talked about, at line speed, at data line speed. So that's the requirement, right? You can't be doing this stuff after the fact, after the data has been put on flash or disk or whatever. You got to do it as the blocks or the files or whatever being written. And so this is critical to be able to do this in line. And being able to add those security services. You gave an example of host-based encryption, but I could think of a myriad of these, right, in terms of host access, data classification, the list goes on, and being able to do that at line speed is what's critical. So this is really important, and the overlap or the intersection of security and storage is becoming more and more prevalent. There's the industry analysts are starting to talk about cyber storage, and that's an area where we're very focused on right now. Because, as I said, when you think about the security context, the storage is the last line of defense. We're the last person standing, and we got to put more of those capabilities really close to the data and being able to protect these environments.
So thank you, Denis and Vincent. This has been a very illuminating discussion here.